Good morning, class 6. We are continuing from yesterday's class, that is, chapter Fundamental Concepts of Algebra. We had already discussed few terminologies in the yesterday's class. So today we are going to continue with whatever is left out. Coefficient. Coefficient is any factor or group of factors for a given term. Let's try to understand this with the help of an example. Let's say there is a term 15ABC. So, to find out the coefficient of any of these 15ABC, let's say we have to find the coefficient of A, and the coefficient of A is 15BC. The question is how you get the coefficient of A as 15BC. It's very simple. Just leave this A, since we are finding the coefficient of A, so leave this A. Whatever is left out will be its coefficient. So the coefficient left out will be 15, B and C. So coefficient of A is 15BC. Similarly, coefficient of B is 15AC. You can see that in order to find the coefficient of B, you just need to leave B and the left out terms will be 15AC. So the coefficient of B is 15AC. Similarly, coefficient of 15 is ABC. As you can cancel, as you leave 15 from this term, the left out will be ABC. So coefficient of 15 is ABC. Coefficient of 5A is 3BC. Now you may be thinking that 5A is not there in 15ABC. But if you know that 15 can be broken down in terms of its factors, then 15 will have its factors as 5 into 3. So leaving 5, we have left out 3 from its numeral coefficient, and leaving A, we have BC left out. So therefore 3BC becomes your coefficient for 5A. In this term, this 15 is the number. Thus, this 15 in this term is called as the numeral coefficient in this term 15ABC. Next, we move on to power. As we already know that when you multiply a variable A into A, the answer will be A to the power 2. This 2 is the power and this A is the base. Similarly, if you take another example where A is getting multiplied by itself 6 times, so we can write down this as A to the power 6, where this 6 is the power and A is the base. Suppose if we have any number and its power is 0, then its value will be equal to 1. Let's see the example over here. A can be any number and its power is 0. Therefore, the whole value will be equal to 1. If there is any number in place of A, like 1000, but its power is 0, then the whole value will be equal to 1. So whatever is the base, if its power is 0, then the value will always be equal to 1. Next, if we have a term 20a squared b cube. Then how we can expand it is just write the factors of 20. The factors of 20 is 2 into 2 into 5. A squared can be written as a into a, and b squared can be written as b into b into b. So this is how we expand a given term. So this way we can easily find out the coefficients of any of the term. Similarly, if 10m cube n squared is given, then we can again expand it in the form of its factors. 10 can be written as 2 into 5. M cubed can be written as m into m into m, and n squared can be written as n into n. Next, we move on to degree. What is a degree? The degree of any polynomial is the greatest of the exponents in its terms. By this, we understand with the help of an example. Let's see. Suppose there is a polynomial. Over here there are two terms, so obviously it's a binomial. So 4x squared plus 3x cubed, if you see properly, the power of the variable x, over here, in the first term is 2 and in the second term it's 3. So we can see that the term 3x cube has the highest power, that is 3. So the degree of this polynomial is 3. This 3 is actually the power of the greatest power of the variable. So compared to this power 2 and the power 3, the highest power is 3, therefore its degree is 3. Let's take another example. There is a trinomial 2x squared y cubed plus 5x cubed minus 4y squared. So there are three terms. If you check properly, x has the square as a power, y has cube as a power. Again over here, x has the power 3 and y has the power 2. Now it's a little bit confusing because there are two powers with 3. So what is the degree? Is it that the degree is equal to 3? Have a look properly. 2x squared y cube has the power 2 and the power 3 in the same term. So these two powers 2 and 3 will be added and the result will be 5. Hence, the degree of this polynomial is 5. So in order to find out the degree of this kind of terms, where in a single term you have different variables with different powers, we add up all the powers and we obtain the result. Whichever power with the result is maximum, that will be the degree of the given polynomial. So by this we come to an end of our video. So let's have a look at assignment that you are going to do. Go to exercise 18b, page number 168, and do question number 7, 8, 9 and 10. I hope you liked this video and you understood the terminologies of algebra. Thank you.